All right, so in this video, we're going to talk about complex numbers. So we're going to start by talking about the real numbers first. So with real numbers, we usually think about these on a number line. So I'll draw a little number line, 0, 1, 2, -1, -2, and we would plot these real numbers on the real number line. So say I would plot 1 as the point there. We can also use real numbers to solve equations. So if I was going to solve x squared minus 2 equals 0, I would say that the numbers that satisfy this equation are x equals plus or minus square root of 2. Graphically, that would look like a parabola in the xy plane that has two roots. So if I drew this parabola, something like this, and there's two roots, and the roots are where this parabola crosses the x-axis, so -√2 and √2. Okay, imaginary numbers come from wanting to solve equations where it seems like there's no solution in the real numbers. So say we wanted to solve the equation x squared plus 1 equals 0. In calculus, you might have said, oh, this has no solution. But really what you meant is that this has no real solutions. Its solutions are imaginary. And if we take that analogy back to drawing a parabola, so in the xy plane, this parabola, the reason we say it has no real solutions is that this parabola sits up here, and it looks like, well, it doesn't cross the x-axis anywhere. So we don't really have a way to say that there's a root on the real line. But we're going to think about roots that are imaginary. So if I can scroll down to the next page here, we're going to define the number I to satisfy the relation, satisfy the equation I squared equals -1. And I is called, the number I is called the imaginary unit. You can also have imaginary numbers. So imaginary numbers are a constant. Imaginary numbers look like a constant times I, where C, this constant, is a real number. So if I can give some examples, we've got 3i, 7i, -2i. These are all imaginary numbers. And notice that if you square an imaginary number, let's say if I took 3i squared, well, that would be the same as doing 3 squared times I squared. Notice that I squared is equal to -1. So really we've got 3 squared times -1, and that gives us -9. All right, so I also want to talk about powers of the number I. So let's go to another page. Powers of I. And the powers of I kind of follow this cyclic pattern. So what I mean by that is if I take I to the first power, that's just I. If I take I to the second power, that's I times I, but really, this is kind of the definition of I. I squared is -1. That comes from how we defined the imaginary unit. I cubed, well, that's I squared times I. I squared, I can replace by -1. So really I have -1 times I. negative I. And I to the fourth is, you could think about it as I cubed times I, or I could think about it as I squared times I squared. Each of these is negative 1. So negative 1 times negative 1 is 1. And the last one I'm going to do is I to the fifth. That's going to be I to the fourth times I. Well, that's 1 times I, because I to the fourth is 1. So I'll replace that with 1, and I get I. So notice that when I get to I to the fifth, I have just repeated, I get back to this beginning case of I to the first. So if I had taken, then I go to I to the sixth, I'll get negative 1. The pattern repeats. I, negative 1, negative I, 1. I, negative 1, negative I, 1. So this repeats over and over again. You can compute some of those for yourself if you'd like to see. So next, we have complex numbers, or we have imaginary numbers and real numbers. We're going to put those together to form what are called complex numbers. So a complex numbers have the form, I'll usually call them Z or W, or you can give them any letter, but usually they're called Z equals A plus BI, where A and B are real numbers. Some examples of complex numbers are, you could even have the number 2. It's a real number, but it's got 0 imaginary part. 3 plus 2i, 4 plus 20i, 3 minus 3i, negative 2i. That's an imaginary number. So here I would say this is also a real number, but you could think of it as a complex number with 0 imaginary part. These are all complex numbers. They have non-zero real and non-zero imaginary parts. And this last number here, you could call it a purely imaginary number. So there's no real part. Oops. Imaginary. Cool. Now, when I say real and imaginary parts, the real part of a complex number is given by the real number out front, so A. So maybe I'll write this up here in green. A here would be the real part, and B would be the imaginary part. Notice that, I want to point this out, that the imaginary part is just B. It is not B times I. So you don't include the I with the imaginary part. It's just B. So quick example. The real part of 3 plus 2i is 3. The imaginary part of 3 plus 2i is 2. So just 2 by itself, not 2 times I. Let me scroll up a little so maybe you can see that better. Okay. I'm sorry. There we go. All right. And then I also want to talk a little bit about the complex plane. So if I go over here and talk about the complex plane, let's remember that we started our discussion with the real line. So we've got the real, actually, let me not draw that yet. This is the real line. And we said, okay, here's 0, 1, 2, 3, 4. Maybe I'll move this over a tiny bit. -1, -2, -3, -4. That's the real line. But if I want to plot a complex number, I don't have any i's down here. There's really nowhere for me to put that imaginary part. So what we do is we extend this into another dimension. We make this a 2-dimensional plane. So this is the imaginary axis, denoted by IM. And on this axis I have I, 2i, 3i, 4i, and then in the bottom here I've got -i, -2i, -3i, -4i, etc. I'm going to go ahead and plot some complex numbers. So the complex number 4 plus 3i, I would go to the right 4 along the real axis, and then I would go up 1, 2, 3. So I'm going to plot that right here. 4 plus 3i. I can plot the point -1 plus 2i, or let's do -2 plus 2i. So I'll go over to the left by 2 and up by 2. That's -2 plus 2i. I'm going to plot some more in the other quadrants here. So -3 minus 2i means I go over to the left by -3 and down to -2. -3 minus 2i. And then I can plot something like 4 minus 3i, or maybe let's do 2 minus i. 2 minus i will be down here. You can also plot real and imaginary, purely imaginary numbers on the complex plane. A real number would just show up exactly on the real axis. So the number -2, I would plot there. If I also wanted to plot, let's see, use pink color here. Sorry, I'm just trying to find another color. Maybe I want to plot a purely imaginary number. Well, if I wanted to plot the number 2i, I would plot that directly onto the imaginary axis. Okay. All right. So that's how you plot points in the complex plane. I want to talk quickly about the complex conjugate. So let me scroll down. The complex conjugate of a complex number. Well, if I have z equals a plus bi, the complex conjugate, which is denoted with z, a little bar on top, is a minus bi. So the key here is that we change the sign of the imaginary part. I'm going to write down 2 examples. So if I have z equals 4 plus 2i, the conjugate of z is going to be 4 minus 2i. Similarly, if I have z equals -2 minus 3i, the conjugate is going to be -2 plus 3i. So if you start out with a negative imaginary part, you take the conjugate, you change that to a positive. So really you're changing the sign of the imaginary part of the complex number. So let's look very quickly at what that means in the complex plane. Let's plot some of the conjugates of these points. So the conjugate of 4 plus 3i will be 4 minus 3i. Let's go ahead and plot that. 4 minus 3i. Oh, let me use the same color that I used before. 4 minus 3i. Let's plot some of the other ones. So 2 minus i, the conjugate is going to be 2 plus I. So that'll go right there. The conjugate of 2i, is going to be -2i, because remember, we just changed the sign of the imaginary part. So that's -2i. 2i, -2i. This point number over here, -2, is a real number. There is no real part. So the conjugate of this number is just itself. So let me write this down. For a real number, we would have a plus 0i. And the conjugate would just be a minus 0i, but 0 and minus 0 are both 0. So the conjugate just doesn't change a real number. Another way to think about it is that if you have a number z that equals its conjugate, then that number has to be real. Is a real number. So these are just sort of side notes that you might keep in mind. The conjugate does not change the real number. So I'm just going to put that, maybe I'll put this in the bottom corner here. All right, let's finish this graph here. Sorry. Get my green color. The conjugate of -2 plus 2i is -2 minus 2i, so I'm going to end up down here. And the conjugate of -3 minus 2i is -3 plus 2i, so I end up here. And notice that taking the conjugate of a complex number reflects it across the real axis, because we've just changed kind of the vertical component of our point to be negative. So I'm just reflecting across the x-axis, or the real axis. Okay, the last thing I want to talk about in this video is adding complex numbers, and for that we're just going to combine like terms. So down here, adding complex numbers. This just means we're going to add the real parts together and then we'll add the imaginary parts together. So let's let, just like we had up here, let's let z equal 4 plus 2i, and maybe I'll use a different letter. Let's say w is -2 minus 3i. I'm going to scroll down a bit here. If I wanted to add z plus w, well, that's 4 plus 2i, that's z, plus -2 minus 3i, that's w. And I'm going to combine like terms. So the things that don't have I next to them, I'm going to combine those together. And the things that do have I will combine those. So I'm going to get 4 minus 2 will give me a 2, and 2 minus 3 will give me a -1. And that's how you add complex numbers. So I hope you found this video helpful. Let me know if you have any questions.